Probability is just the likelihood that something will occur. And when we're going to calculate probability, you need to take the number that work in your event and divide it by the number of total things that there are. So for instance, on this first example, if we have 3 red, 2 blue, and 5 green marbles in a bowl, that means we have a total of 10 marbles. So the probability of drawing out a red marble would be 3 out of 10. The probability of drawing out a pink marble, there aren't any, so that's going to be 0. So the lowest probability you can ever have is 0. That means the event will never happen. If it's definitely going to happen, then it would be 100%. You can write probabilities in fractions, in decimals, or in percentage form. For the next two, the probability of drawing out 2 red marbles in a row, if you put the first one back, on this one we're going to have to multiply those together. So 2 red marbles would be 3 out of 10. We put the marble back, so there's still 3 red marbles out of 10. So the probability would be 9 out of 100. The probability of drawing out 2 red marbles in a row, if you don't put the first one back, that changes things a little bit. So the first probability would still be 3 out of 10, but if we don't put the marble back, there's only 2 red ones left out of a total of 9. So if we multiply those two fractions together, we would get, let's see, these would reduce, so 1 out of 15 it looks like. Then the last one, the odds of drawing out a blue marble. Odds are a little different because we're comparing the number that work compared to the number that don't work. So in our bowl there are 2 blue marbles and there are 8 not blue marbles, which means our 2 numbers should add up to our total, and then we can still reduce it, so it would be 1 to 4. We don't use the phrase out of an odds because we're not comparing to the total anymore. So if we're looking at probabilities, we're going to take this and we're going to put it into a geometric setting. So the probability of randomly hitting a green point or a point in the green region, we would need to know what the area of the green region is compared to the total area. So probability is simply how likely it is that an event will occur. So the number that work compared to the total number of items. If it's never going to happen, our probability is going to be 0. If it's definitely going to happen, we have a probability of 1. So 1 is the biggest we could have, or 100%. Geometric probabilities are just the probability that involves a geometric measure, such as length or area. There's 2 different types of probability. There's theoretical probability, and that's what we generally think of when we're talking about probabilities. Because what we're thinking about is what should happen. That doesn't guarantee that that's what's going to happen. Sorry about that. But what's going to happen would be the experimental probability. The theoretical probability would be what should happen. And that's generally what we look at when we're talking about probabilities. People usually think about the theoretical. In order to do an experimental probability, we'd actually have to collect our own data. And we're not going to do that for right now. So if we look over here for a geometric probability, the probability that a randomly selected point lies in area M. So in order to do that, we would need to calculate the area of triangle M, and we're simply going to divide that by the area of rectangle J. So probability, the part that works, so that would be the area of the triangle compared to the area of the rectangle. So for an example, we have a circular hole on a target that has a radius of 1/2 foot. If a beanbag is equally likely to land on any point on the target, the probability that the beanbag goes through one of the holes. So if we think about this, what we're looking at is, for our top number, the probability of our 4 circles, so we need the area of those, compared to the area of the rectangle. So each circle, it says, has a radius of 1/2 foot. So the area of one circle, radius squared, would be 1/4 times pi. And then we have 4 of those, 4 circles. So a fourth times 4 just cancels out. So the probability of our circle would be pi. And then the rectangle is 3 by 4, so it would be 12. You can leave that as a fraction or you can divide it out if you want to. Either's fine. But pi over 12 would be the probability that we're going to hit it. In your notes, you have this picture. I think you're missing a few numbers. So plug in or fill in all these 8s. And then the probability that a randomly chosen point in the figure lies in the green shaded region. So that would be this triangle on this end and this triangle on this end. So we need the area of those 2 triangles compared to the area of the entire rectangle. So our triangles each have a base of 16 and a height of 8. So our area would be 16 times 8 divided by 2, but we have 2 of them. So 16 times 8 is, let's see, 16 times 8, 128 for our 2 triangles. And then the rectangle is whatever 24 times 16 is. Let me find a calculator real quick here. 24 times 16. You guys should have this by now. 24 times 16 is 384. And we could reduce that if you want to. You can turn it into a decimal if you want to, or you can turn it into a percentage if you want to. But 128 to 130 or to 384. So what you're going to do is you are going to take a few minutes with your group and you are going to work on these 4 questions. So the probability that a point chosen at random in the figure lies in the shaded region. So find the area of the shaded region compared to the area of the total shape. So do these next 4 questions with your group.